Now we could see, we could explain, and you could learn some security aspects that are supported by some IP version 6 options, extensions. Then with the extensions of IP version 6, mechanism for encryption, integrity assurance, and the authentication have been integrated into the protocol stack at the level of internet layer, which can also be used in the previous IP version 4 protocol. The previous IP version 4 protocol, in fact, those security aspects are supported in what is called IPSec standard. Two main enhancements are responsible for this: the implementation of the AH authentication header and the introduction of the ESCP, that is encapsulating security payload. These mechanisms can be used individually or in combination. The exact definition of the AH authentication header and ESP encapsulating security payload can be found in those RFCs for more detail. Then authentication header. The authentication header provides the services of connectionless integrity and authenticity of data origin at the IP level. Remember, integrity in order to avoid that a typical middle man-in-the-middle attack could modify the content of the information exchange across the network, and this mechanism permits to detect that some modification were performed in the content. Then a problem of integrity could be detected, and the authenticity, in order to avoid that someone could replace the ID of some host or some process, and we need to guarantee that if someone send information, we are sure that is that identity the original one and not a fake one. When using the authentication header, it can be seen whether packet contents have been changed or even falsified by untrusted instances in the network. The functionality of the authentication header lies in a so-called cryptographic checksum, that is a typical hash. And I repeat this: the functionality of authentication header lies in a so-called cryptographic checksum, that is a message digest or fingerprint. Is something that is generated using typically secure hash functions, and which is formed and encrypted to check the entire IP packet content, what is called the digital signature. In the case of manipulation of the package content, this is indicated by an error in the verification and comparison with the decrypted signature. Then remember, authentication header use typically cryptographic algorithm in order to check the integrity of the content of the message of the data and the authenticity, that is the identification of the end systems. Then typically the IP header in the next header specify that there is a IAH, that is an authentication header, and the authentication header specify different parameters. For instance, the security parameter index, the sequence number, and the authentication data. That is the hash information, the digest information, the fingerprint information. For instance, those are typically hash secure hash functions, SHA-1 or MD5, Message Digest version 5. The ESP, that is the ESP header. The ESP header provides the service of confidentiality, authenticity of data origin, and connectionless integrity. That is, particularly ESP provide, compared with AH, confidentiality, that is privacy of the information that is transmitted. The ESP encapsulates the data to be protected and, if necessary, encrypts it using symmetrical algorithms. That is typically encryption or cipher algorithms that could be or symmetrical ciphers or asymmetrical ciphers. That is public secret keys in order to exchange the encrypted information. Then, in this case, the next header of the IP header points to the ESP header, and for instance, the ESP header, the next header points to the old IP header, that is the original IP header of the datagram, and in that way we could encrypt, we could protect all the information of the original packet or the original datagram, including not only the payload of the datagram but the header of the datagram. This is one of the options of the encrypted information, and then both headers, AH and ESP, can basically be operated in two different working modes, either tunnel mode or transport mode. And this is typically a tunnel mode, but we will see the difference between the two modes. The operating mode, transport mode, if IP is operated in transport mode, only the IP datagrams from the higher layers are protected. That is, only the payload of the IP datagram. Instead of that, the operating mode, tunnel mode, if IP is operating in tunnel mode, the entire IP packet, including all header information, is protected. The entire IP packet is packaged into a new IP packet in tunnel mode. That is what we see typically in this illustration. For safety reasons, tunnel mode is definitely preferable to transport mode. In this way, for example, IP spoofing attacks can be better intercepted. This is because not only the payload of the IP datagram is encrypted, but the header of the IP datagram is encrypted too. In this illustration, we could see that, in fact, if this is the IP, the original IP datagram with payload and header, in the transport mode, the IP header is transferred in clear text, but only the payload is encrypted. All this encrypted, and this is the information added in the header of the ESP extension. In the tunnel mode, in fact, This is the header of the original datagram and the payload. Then not only we encrypt the payload of the datagram, but the header of the datagram too. Well, finally, we could talk about the transition from IP version 4 to IP version 6, because in fact, all the internet functions with a lot of hosts and servers that still use IP version 4 protocol. Then there are different strategies to perform the transition from the internet that functions using IP version 4 to the use of the IP version 6. The use of a dual stack defined in this RFC is the main important strategy. In that strategy, the new network nodes in the internet will support, in fact, the two stacks, that is the two protocols, the IP version 4 and the IP version 6 protocol. But in fact, there are a lot of legacy systems that are running with IP version 4 only stack. Typically, platforms that only support IP version 4 only. In this way, several different strategies are implemented in order to facilitate the communication between the new nodes that support typically IP version 6 and IP version 4 and communicate with, for instance, the IP version 4 only devices. And there could be two particular configurations where some new hosts only are IP version 6 only nodes. Then there are typically several strategies. One is the 6 to 4 tunneling. Tunnels are set up on the internet in order to be able to transport IP version 6 packets over IP version 4 network. Then in that case, we use a particular prefix, and we could transport, in fact, the IP version 6 datagrams encapsulated into IP version 4 datagrams. Or, for instance, the strategy called NAT64 from network address translation from version 6 to version 4, or carrier grade NAT or dual stack light. In fact, for instance, in order to illustrate some example of those strategies, here we are. This is a typical IP version 4 network with some old web server, for instance, that only listen that are only IP version 4 hosts. Then if this is a typical IP version 6 client that need to access to this server, this host need to perform a lookup, a DNS lookup, asking for the name of this web server. But in this case, a particular DNS server receive the lookup, the query, and ask which is the IP version 4 address of the destination web server, and transform this information that is in fact a resource record type A in a DNS resource record type an address of IP version 6. Then transform this information in this one. Remember, those last 32 last bits of this IP version 6 address is the hexadecimal notation of this IP version 4 address. In that way, then the IP version 6 only client will try to establish a TCP connection with this IP version 6 address that is in fact supported by this device, special device called NAT, Network Address Translation 64. And this is the device that will perform then the connection TCP between those two end systems. But in this device, we will perform a special case of address translation that associate this destination address with this other destination address. And then in that way, the messages, when the messages go from the IP version 6 to the IP version 4 network, the destination address of the IP version 6 will be transformed in the destination address of the IP version 4 datagram. And when the responses comes from the web server, coming from this source IP version 4 source address, in this device, the datagram will be transformed in order to map the source address, this IP version 4 source address, in this other IP version 6 source address. And in this way, we could resolve the problem of one IP version 6 only host that need to establish a connection with the IP version 4 only server. And there are other strategies, but typically those other strategies are performed by the ISPs. And one is the carrier grade NAT, and the other is the dual stack light strategy.